My name is Lis Mortensen. I'm a physical geographer at an institution called the EDU-ARCTIC, which is the Faroese Geological Survey. So I live in the Faroe Islands, and I'll show you a map in a little bit where that is. It's a little place far north. So let me start the lesson. Let me say something before we move on. Maybe some of you have been to these lessons before. Maybe some of you haven't. You are free to write on the chat when you have any questions, and I have a helper with me today, so we can follow up on the questions that you have. So please do that. If there is anything you would like to know, then write it on the chat. This image, we see a fjord in the Faroe Islands. We see the mountainsides. We see a valley bottom, if you like, a deep valley. It's called Kaldbaksfjörður. This is a typical Faroese landscape. It's if you look at the parts here that I'm trying to write out here, you can see these lines in the landscape. You can see them on the other side of the fjord as well. See how the whole landscape is kind of built up of layer upon layer of volcanic lava, actually. That's about 60 million years old. So the Faroe Islands used to be lava, or was built up as in volcanic by volcanic activity. So it was built up by lava, volcanoes spraying up lava that ran over a big surface, and those layers that I just pointed out to you show old landscape surfaces. So that's how the landscape was built up, layer upon layer of lava layers 60 million years ago. And this happened when the North Atlantic Ocean opened about that time in this area. What we're going to hear about is how this landscape was transformed from this quite flat landscape to the deeply eroded, glaciated landscape that we are looking at today. So let's look a little bit about the Faroe Islands. It's a very small place, a land area comprising 18 islands. It's in the middle between Iceland here and Norway and Scotland. So these little islands, they have a total land area of approximately 1,400 square kilometers. If you look at the red line, that's all around the islands, land area here, all around here, you can see that this is the border around the Faroe Islands, and that total land area is about 275,000 square kilometers. It's a lot of sea. This being in the middle of the sea has a great influence on the evolution of the Faroese landscape. So we're looking at now at 18 islands, and many of them are quite narrow and long. The islands have a total population of about 49,000 people. Actually, it's a little bit more. I heard just a few days ago that in a very, very short time, we're going to hit the number of being 50,000 people for the first time ever. So that's a bit exciting number that's coming. In Tórshavn, which is in this area here, that's where I live, and that's where we are having this lesson today. We are about 20,000 people living in that area. The islands are quite small. You can probably never come further away from the sea than about 5 kilometers. Then you get closer to sea on the other side. But even though the area is so small, the highest mountaintop is actually 880 meters high. So that means it's a quite mountainous landscape. It's a high relief landscape. It's steep in many places. These are some typical pictures, images from what is characteristic about the Faroese landscape. It's very high cliffs facing the ocean in many places. The very highest cliff is in the northern area, and it's 750 meters straight into the ocean. The highest mountain we mentioned just earlier is about 880 meters high. And we see again this picture from the typical landscape of a fjord and a valley with these steep topography and narrow fjords and sounds between the islands. Here's another image where we can see how the ocean waves are eating very fast, actually, into the land. It's volcanic rock, it's basalt, built up by basalt, and here again we can see this layering of lava, of basaltic layers that once built the whole area up. And we can see how the ocean now is eating so much into the land that it's a sheer rock wall facing the sea. This very flat land area was transformed by numerous glaciations, by numerous ice ages, the past maybe 2.5 million years. This image is from Svalbard. It's a winter image from Svalbard, and it shows maybe how we can imagine the Faroes would have looked like when the last ice age was at its maximum. So what we're looking at is mountains that are reaching up of the ice, and then we can see that big glaciers are running out through the landscape. These valleys are filled with ice, and the glaciers are slowly moving their way out through the landscape. If we saw this same image during summer, then these mountain tops would have been ice-free and would have been more black and gray, but the glaciers that fill the valleys, they would still be there. They exist for many, many years, thousands of years actually. And we would see a landscape filled with valley glaciers where mountain tops reach up above the ice and become what we call nunataks. They are mountain tops that reach up above the ice cover. So this is pretty much how we would imagine the Faroes looked like about 20,000 years ago, when the last ice age was at its maximum. And this process was the process that completely transformed the quite flat landscape to these very deeply eroded deep fiords and valleys that we can see today. The ice ages, they change the environment on Earth quite a bit. On this image we can see down on the northern hemisphere, and on the picture to the left we see ice ages, and we see down on the North Pole, and the white parts on the image show continents that have an ice sheet, that have ice cover, not snow cover, but ice cover, thick ice. The gray areas that you can see, they show sea ice, and they are ice covers on the sea. They are floating on the sea, and they can be maybe a few meters thick at the most. On the image to the right, we see the situation today at summertime, and we can see the gray area north of Greenland. Let me point Greenland out to you. This is Greenland, and the gray area north of Greenland here is the sea ice that we have in the northern hemisphere today, in the Arctic Sea today. That sea ice is changing volume quite a bit at the moment, but in the summertime it becomes smaller, and in the wintertime it's obviously a bit bigger. And actually we can see on this image that the only ice sheet that we have left on Earth in the northern hemisphere today is the ice sheet on Greenland. The ice sheet on the other side, on the south side, is the Antarctic ice sheet. So these are the situation when it's not an ice age. And we can ask the question, why do we have ice ages? How long do they last? We will look a little bit at that. But first we will look a little bit at what is it? Why do we have ice ages? Why does the climate change so much that sometimes we have an ice age and sometimes we have an interglacial, we have a warm period between ice ages? One of the reasons is the sun. The sun has sometimes more radiation and sometimes a little bit less, so that's one factor. One important factor is the orbit, the shape of the orbit of Earth around the sun. Another very important factor is the tilt. When we have the Earth, it tilts a little bit. That's one of the very important factors, is the change of this tilt. And then we have the precession. The precession is something that you probably know very well. It's a strange word. But if you, I should have had a little toy with me. But if you have this toy that you can turn it around on the table, and it spins and spins and spins and spins and spins on the table until it falls down. And you know, when you spin it, you know how the axis spins itself. It spins around and kind of spins with the axis. Try that toy and look at it. That's the precession. That's the tilt, the spinning of the axis itself without changing the tilt. So that's even one of these important factors. Let's look at the tilt. The Earth tilt can change. Sometimes it is 24.5 degrees, and sometimes it is 25.5 degrees. That little change, it doesn't sound much, but it has a great influence. At the moment, the Earth tilt now is 23.5 degrees. This tilt is the reason that we have seasons every year, that we have spring and summer and fall and winter. That's because of the tilt of the Earth. And another thing that we get from the Earth tilt, which is 23.5 today, is the polar circle. The North Polar Circle is, if you are north of the North Polar Circle, you have midnight sun, and the further north you go, the more days or more nights you have with midnight sun. And the same if you go to the southern polar circle. Inside that you will have midnight sun during the summer. And if you go to the northernmost place, you will have just one long day a year and one long night a year. So that has a big influence, the tilt. The orbit of Earth around the Sun can be more circular, and then sometimes it can be more ellipsoidal, so more like an ellipse or more circular. And the change of this shape of the orbit, it's called the eccentricity. It gives very strong climate changes with a period of about 95,000 years, 125,000 years, and 400,000 years. And you can see the curve below. You can see the blue curve that we have below here. How the climate changes depending on the shape of the orbit of the Earth around the Sun. If you look at this figure, we have on the left side we have the now situation, and then we go 200,000 years back in time and 400,000 years back in time, and we go up to 1 million years back in time, 1,000 years back in time. This period with these climate changes from ice ages to interglacials to periods between ice ages has lasted the past about 2.6 million years. And then we can put all these factors together. We have the precession in the top here. which changes with a period of 19, 22, and 24,000 years. And we can see the influence that this gives us of how that changes the climate on Earth. The precession, remember, was the toy that it starts spinning on the table, and that's how the Earth spins around its own axis as well. The next was the obliquity, and that's the tilt of the Earth axis, which today is 23.5 degrees, and it can change just a few degrees, and you can see how much that influences the climate on Earth, with a period of about 41,000 years. The eccentricity was the shape of the orbit of the Sun, the Earth around the Sun, which is sometimes circular and sometimes more like an ellipse. And this shape of the orbit, the eccentricity, has a big influence on the change of the climate. And it changes with a period of 95,000 years, 125,000 years, and 400,000 years. And then finally we have the strength of the Sun, and we can see how much that changes. Here we are looking at 65 degrees north, just as an example. And the result of these factors, there are probably more factors, but these are some of the very most important factors that are called the Milankovitch cycles. They correlate very well with the Earth's glaciations. Well, actually, not only in the past 2.5 million years, but for a very, very long time, this has been the situation on Earth. It's just that it's not always turns into ice ages, but it always gives climate changes. So let's look a little bit at the last part of the figure here, where we look at the stages of the glaciation. See if I can change here. And we see the situation today now. We are in a gray area here, and you can see that these gray zones, they happen with the various intervals, and they show the warm periods, the interglacial periods, the periods between ice ages. Then we have the wide area in between two gray areas, and they show us the cold periods, the glaciations. And the whole figure goes 1 million years back in time. So when the figure is numbers are high, so the black line is high on the graph, that's the warm, the hot periods of the climate, and when it's low, it's the cold stages, and that's where we have the ice ages. So on this image we can count how many ice ages there are, and we can look at the last ice age. Let me take a little line here. Let's look at the last ice age here. And we can see that the climate gets colder and colder. It started maybe 120,000 years ago. A little bit less than that, perhaps. And the ice age, the characteristic way of the ice age was that it got cold, and then it got a bit colder and a bit colder. A lot of changes on the way, and a bit colder through a very, very long time. actually about 100,000 years. So the Ice Age, that's one of the characteristics that you can get from this image, is that the interglacials are shorter than the glaciations. So the Ice Ages, they last for a longer time than the warmer periods. Another interesting fact that you can get from this image is that the Ice Age got colder and colder and colder, and then about the time when it was at the very coldest, it all of a sudden changed and got warm in a very short time, actually, geologically speaking at least, over a few thousand years. So it has the ability of changing a lot. The Earth's climate has the ability of changing a lot, and we can see that the characteristic image of an Ice Age is that it gets colder and colder over a very, very long period of time, and then when it is at its maximum, when the Ice Age is at its coldest, then it will get warm within a short time and turn into a warm period, into an interglacial. The interglacial that we have today has a name. It's called the Holocene. And the last Ice Age that we just had a look at also has a name. It's called the Glacial Ice Age. So when we know that Ice Ages can happen, we know that the main factors that influence the Earth's climate so that we get an Ice Age. Then our work is to go into the landscape and see how would the climate change that we know has happened, would that climate change this landscape that I am visiting or working in? And again, we look at the valley that we have seen a few times. We see the steep valley sides on both sides of the fjord, and we see this form is kind of a valley with the steep valley sides and a broad valley bottom, and we call valleys like that, we call them U-shaped valleys. And they are very characteristic for a glaciated landscape, for a landscape that has been shaped by glaciers. So we can conclude from many factors, from the shape is one thing, and then we can find other evidence that we will look at, that this was a place for a glacier during the last Ice Age. In the Faroe Islands, there are no glaciers today. There are many reasons for that. This place is located about 62 degrees north, but the climate and the close vicinity to the ocean has the effect that this is a very oceanic landscape. It's very influenced by the sea, by the ocean currents, which happen to be warm, which are part of the North Atlantic current, of the Gulf current, it's often called here. So here we look at a valley that was once filled with a glacier that was running out through this landscape, and over not one ice age but many ice ages, this has reshaped the flat land area to a U-shaped glaciated valley that we look at today. Here we look at another image where again we can see these round shape, and this tells us that a glacier filled this valley during the last ice age and the ice ages before that, and a characteristic feature is this ridge in front of the glacier that sometimes it is a moraine, it's filled with the sediments from the glacier, and in this case it's solid rock actually. We have many ways of mapping the direction of the glaciers. We see these ice scoring, and the ice scoring, the scratches that the ice makes in the rock comes because there's rock frozen underneath the glacier, and that the rock kind of grinds the rock and gives these small scratches that we see in the rock. Don't confuse it with these large pieces of broken rock, because there it may have worked with weaknesses in the rock and are not ice scoring. The ice scoring are just these scratches on the rock, and that tells us the direction of the glacier. In many places we can see material moved by a glacier. In this case we can see this earth next to these boathouses, and we can see how the upper part is material moved during the last ice age, the Glacial ice age, and then we can see another part, another kind of material that was actually placed there at the time of the last interglacial, about 130,000 years ago. And then in the lowest part we see an older ice age, the Sale ice age. So this is an interesting window into a glacial history that we are looking at. In many places in the Faroes you can see these huge boulders that are just placed like small pieces of furniture around the landscape, and you wonder, how did that rock end up there? There's not a steep side where it could have fallen down and placed there. It's just a flat place. How can such a big rock just lie there all of a sudden? Rocks like that, they will be moved by glaciers. So they are called glacial erratics. They are boulders moved by glaciers. And it tells us again about the size of the glaciers and the direction. And then we have boulder landscapes, not one boulder, but many, many, many boulders. And in this case, this boulder landscape, when we go further up into the air and look at that same side, we see that it's not just a boulder landscape, it's actually a rock glacier. It's a whole landscape of rocks that has a frozen core and has just moved out through the landscape, and just as if it was ice. And we see these beautiful, very clear signs of rocks moving out through the landscape. And now when the ice is gone the rocks are still there, and they show us what happened during the last ice age. In the Faroe Islands, we have had some wondering: did the ice come from north or did it come from south? Did it come from the North Pole? Did it come from the huge ice sheet that was over Scandinavia? The first investigations in the Faroes in the early 1800s showed that it came from north. And then more detailed mapping, as geologists and geoscientists went into the landscape and mapped it, it showed that they could turn the arrow 180 degrees the other way. It actually was pointing north and not south, as the first investigation showed. And then further mapping around the islands has given us the necessary knowledge about how the ice changed the landscape and how it behaved in these remote islands. And we can see that in the northern part it was pointing north, in the western part it was pointing southwest, and in the eastern part it was pointing southeast. And this shows us that when we model the ice cover around all the islands, it turns into an independent glaciated land area. So the islands have apparently been too small to occupy a very thick layer of ice, and when it has been at its very, very thickest, as we see on this image, and we imagine now that the 18 islands are underneath this ice cover, we can see that the glaciers shown with these yellow arrows, they radiate to all sides around the islands. So this has been an independent glaciated area with no connection to the ice sheet of Scandinavia or Iceland or Scotland. It's too remote. So finally, we see an image of the islands from a beautiful summer day, and we see the remnants of the land area that began as a very flat area built up by basaltic layers that was later glaciated and deeply eroded by numerous or within numerous ice ages, and turned into this landscape with the very high or very steep topography and separate islands with the narrow sounds and fjords. So this is how this land area changed through severe climate changes, you could say.